viewers to another episode on ASUG 12 exams. So in this episode we are looking at the 2020 science paper 2, which is basically chemistry, and chemistry carries 85 marks just like physics. So let us move straight into section A, which has 20 multiple choice and each question carries 1 mark. That is 20 marks out of 85. Question 1. A learner wanted an apparatus that he would use to accurately measure 10.5 centimeter cubic of dilute hydrochloric acid to prepare a salt of sodium metal by neutralization. Which one of the following apparatus would you advise him to use? So the question is asking us what can we advise him to use, and this is the key: accurately measure 10.5 centimeter cubic. So we look at the option beaker. So the beaker is used to hold and mix a liquid. So what you notice here in this case, this one is not correct. If you look at B, the bullet, so the bullet is used to transfer and measure liquid, and the degree of accuracy is 0.1 centimeter cubic. So what you notice here is this one would fit well. So ideally B would be one of the answers. But let us look at the other one. C, pipette. Okay, so the pipette is also used to transfer. Now this one is to transfer the measured volume of liquid, and these one are 10 centimeter cubic and 25 centimeter cubic. These are the fixed one that are normally used. These are the common ones. So if you look at 10.5, this one would not be ideal. Volumetric flask is also used to measure a fixed amount of volume, but in this case this is not fixed, 10.5, so this one is not also correct. So B is the correct answer on A. Number 2, in which conversion do water molecules lose energy? So we need to know how does the water molecule lose energy. So what happens is when water changes, okay, from let us say from water to ice, the average energy of the molecules will decrease. Okay, so what is happening here in this case is, so here is increasing. It's the opposite of from water to ice. Then if you look at here, this is a decrease, okay, which is losing. Then if you look at here, what is inside here, this one is basically is increase. Then from water to vapor here is also increase. Then here is a decrease. Okay, so now when this is happening, what is happening is the amount of heat which will be removed when water changes from basically water to ice will be great enough that the attractive force between the molecules draw molecules together. That's why it's becoming the solid. So let us look at the options now, having understood that. So we have ice to water. Ice to water, this is not true, it's increasing. Then ice to water vapor is also increasing. Then water vapor to ice, yes, so this is water vapor to ice, which is decrease here. So C is correct. If you look at D, water to water vapor is increase, also D is incorrect. So basically this is how you answer this question. Number 3, which of the following best describes metallic bonding? Then we have it is a force of attraction between. So what is metallic bonding? So basically metallic bonding involves a sharing of electrons between atoms of metallic elements. So basically what happens is each metal loses electrons and becomes positively charged. So because of these electrons will form a structure of positively charged ions in a sea of delocalized electrons. So what will happen is because of that the bonding will be formed. So if you look at the options, A, two different types of metals. So it's not necessarily two different types of metals. Okay, not necessarily true. Then what is basically holding the force of attraction between these metals? So we have protons in the nucleus of a metal and the valence electrons of the metal. Not necessarily true. Valence electrons and protons in the nucleus of the non-metal, no, because here there is no non-metal. You see, just metals. So this one is incorrect. Valence of electrons and the metal ions. So D is the best answer here. We look at question 4. Lime water is a strong alkali. What would be the net ionic equation for reaction between lime water and the acid solution of nitric acid? So we have basically this is an acid and this is a lime water is a base. So lime water is basically calcium hydroxide. Okay, this is lime water. So now when a base and acid react, they will form basically a reaction called neutralization reaction, and in that neutralization reaction we're going to have a salt and water. So if you check from the options, we need to see that one of the products should be water. So here there is no water in the ionic equation. There is no water here. There is so from here you can see that A is the best answer. But just to demonstrate on how to get it, this is aqueous. Then we add nitric acid, which is basically HNO3, which is aqueous also. When these react, they will give us basically a salt. So what will be the salt? So the salt will be basically calcium nitrate, then plus, and that's aqueous, plus water, which is liquid. This is what will be given to us. Now what you notice here in this case is basically what is the new product. So what you notice here is the first thing is, let us balance the equation. So here we have 2 plus 1 hydrogen, so we have 3 hydrogen. So what you need to ensure is to ensure that we balance the equation so that we have the balanced case. So what we do is basically we put 2 here so that we have 2 plus 2, which is basically 4. Then here if you put a 2, it will be 4 hydrogen plus this, so the hydrogen balances. Then oxygen, we have 2 here because of this 2. Then we also have 2 here this side. Then here we have 6 plus this side we have 6. Then calcium 1, so it's balanced. So from here we can proceed to write it now in ionic equation. So it will be just write here calcium. So this calcium, because of this 2, it has 2 positives. Then plus we have the hydrogen, the hydroxide part, which is basically will be because of this 2, so it's going to be 2 this with a negative. Okay, then plus, then we have this basically 2 hydrogen plus, then they also plus the 2 nitric ion, which is also in this case a negative. Then this gives us the output, which is in this case the output is the calcium with positive 2, then plus the 2 nitrate with negative, then plus this one, which is a 1, because it's a liquid, it has changed, it's a new product, so we have positive 2 basically water liquid like this. Okay, so now what will happen is you notice that some of these elements are appearing both sides. So what is going to happen is basically this one and this one, they are the same, they will cancel. So we cancel whatever is maintaining to be the same. Okay, we cancel whatever is maintaining to be the same. So what you notice here is in this case is this nitrate and this nitrate is cancelled. So what we end up with this and that. Okay, adding, because this is 2 in the simplified and this one, so we just have this one and this one and this one word. These are the only which remain, so that's how you end up with A. So basically this is how you answer this question. Let us move to question 5. Question 5. A sample of an oxide of manganese is analyzed and it is found that 11 grams of manganese combined with 4.8 grams of oxygen. What is the empirical formula of the oxide? So the question is asking us to find the empirical formula of this oxide. So what do we have? We have 11 grams of manganese and 4.8 grams of oxygen. So for us to find this, the formula for this manganese oxide, we need to know the number of moles. The number of moles, these are standard units that we can compare one to another. So number of moles in a given quantity is equal to mass given divided by mass number. That's basically what we need to do. So we need to write here, we're going to find the number of moles. So here we are going to have manganese, then oxygen. So we've been given 11 grams of manganese, then 4.8 of oxygen. So what we do, we divide to find the number of moles. So we need to know the mass number of these elements. So what we do, we go to the periodic table. So on the periodic table, when you look at the periodic table, is the manganese is here, and this is 55. Then oxygen is here, so this is 16. So we go back and divide by this. So this will be 55, then this will be 16. When we divide this, we discover that 11 divided by 55 is 0.2. Then 4.8 divided by 16, this is basically 0.3. So this is the ratio. So what we do, we need to make them odd numbers. So what we can do is we can multiply all of them by 10 so that they become odd number by 10, so that this one just becomes now 2 to 3, as the ratio 2 to 3. So what this tells us, we have basically 2 manganese, then 3 oxygen. So this is the formula. So when we check out the options, we discover that B is the correct option. Question 6. The diagram below shows a simplified periodic table. The letters used are not symbols of the actual elements. Which element A, B, C, or D is the least metallic? So basically what we need to know is the metallic characteristics of elements on the periodic table decreases as you move from left to the right. So what this tells us in this case is as you move from this direction, they become more metallic. Then here they become non-metallic. So that's what we need to know. So if you look at it, all these elements are in the same period. Okay? So what it means is D will have the least metallic property or characteristics. So D is the answer. A will have the most metallic properties or characteristics. Question 7. Which property shows a decreasing trend in elements from group 1 to group 7 across a period of periodic table? So A, non-metallic characteristic, is not true, because we are moving from group 1 to group 7, which is in this direction. So non-metallic increases. So this is not correct. Then number of electron shells. Okay, so electrons, what we are saying is the number of electron shells. So the number of electron shells are basically these. So they increase as you move down the periods. So this is not true. So all these elements, they have one shell. Okay, then basically C, radius of the electron. So the radius basically increases as you move downward and decreases as you move upward. Then what you notice here is D is reactivity with water. So the least reactive these from group 7, then the most reactive is group 1. So this is decreases. So D is the correct answer. Question 8. Which one of the following elements burns in air to give a compound which dissolves in water to form a solution of pH equal to 2? So we need to choose from the elements that we've been given. Then the solution that it will form should be of pH equals to 2. So this is acidic. So you look at the options. So the option is basically we have aluminium. So when aluminium is burnt in air and then it's dissolved in water, it can't form an acidic, because burnt in air to give us aluminium oxide, which is not acidic. Then hydrogen, most likely when burnt in air, it will give us water, which when dissolved in water, it will still be water. Then sodium, when burnt in air, it will give us sodium oxide, which are basically not acidic. Then D, when burnt in air, sulfur, it will give us sulfur dioxide when react with oxygen. And this sulfur dioxide, when reacted with water by dissolving it in water, it will give us sulfuric acid. Sulfuric acid is basically acidic. So D is the best answer. Number 9. Identify the ion which will give only a clear solution when treated with an excess of aqueous ammonia. Okay, so we want to identify this ion. So you see basically a method of identifying or testing for cations. So we have zinc. So when zinc is reacted with ammonia, this is aqueous ammonia, basically what we are going to end up with the normal is a white precipitate. But when we react it with excess, that precipitate is going to dissolve and form a colorless solution. So A is basically fits this one. It's going to a clear solution. If you look at lead, it will form a white precipitate under normal. Even if we will use excess, the precipitate will still be insoluble in these solutions. So this one is out. Then if you look at ion 2, basically is going to form a green precipitate under normal ammonia. Then excess this precipitate will still remain insoluble. So this is a green precipitate. Then this is clear precipitate in excess. Then this is for ion. Then aluminium, for aluminium basically is going to also form a white precipitate, and this will still remain insoluble. So it will be white precipitate, and it will remain insoluble in excess ammonia, aqueous ammonia. So insoluble. So this one will be insoluble, this one insoluble, this one insoluble, and this one insoluble. Only A will be soluble. So this is a unique way of identifying the zinc cation using excess ammonia aqueous or aqueous ammonia. Number 10. Elena titrates aqueous sodium hydroxide from a bullet with dilute hydrochloric acid in a flask. After the titration, the flask is emptied. What is the correct procedure before the next titration? So basically, we have A, rinse out the conical flask with dilute hydrochloric acid. This will not help, because what will happen is this sodium hydroxide will react with hydrochloric acid, which is dilute. Then all these are aqueous. Then they will give us basically a sodium chloride, which is basically a salt. Then plus and aqueous. then plus this one and this one forms water, which is liquid. So now what will happen is, if you add this, it will become acidic, so we are not cleaning it, so this one is out. Then rinse out the conical flask with aqueous sodium hydroxide. Again, we are not making it clean. Rinse out the conical flask with distilled water. Distilled water is pure, so basically what you notice here is, because there is this salt, okay, it will not further react with water. So this one seems to be the correct. D, use conical flask again without rinsing. You need to rinse it, because in case it remains with this aqueous sodium chloride, or which you need to just ensure that it's cleaned. So basically in this case, C would be the correct answer. Question 11. The rate of chemical reaction is affected by a number of factors. Which of the following would not increase the rate of reaction between a lump of calcium carbonate and the dilute hydrochloric acid? So basically we are looking for the factors that would not increase the rate of reaction. Okay, let us look at the options. Reacting the acid with powdered calcium carbonate. So powdered calcium carbonate will increase the surface area. This basically will increase the rate of reaction, which is basically so this cannot be the answer. Then we look at B, increasing the concentration of the acid. So increasing the concentration of acid will increase basically the number of moles per unit. So this also increases the rate of reaction. So B is incorrect. If you look at C, increasing the temperature in the reaction vessel. So increasing the temperature in the reaction vessel increases the frequency of corrosion. So because the frequency of corrosion increases, the rate of reaction would increase. So C is incorrect. D, increasing the pressure in the reaction vessel. So increasing the pressure in the reaction vessel, this would not affect the rate of reaction, because we have basically the lump, which is, this is solid, and we also have basically a liquid. So pressure won't affect the rate of reaction involving gases. So that's why D is the correct answer. We move to question 12. In 4 separate experiments, identical samples of magnesium ribbon were added in excess to hydrochloric acid. Which experiment will give off hydrogen most slowly? So because this to be slow, it means the rate of reaction will be very slow or weak, because the concentration is less. So we need to look for the experiment which would give us this. So if you look at option A, we have a volume of 50 centimeter cubic, which is in this case the biggest among the option. Then concentration is 0.1, which is the lowest. Okay, so this normally gives us the lowest concentration, which would mean the slowest reaction. So if you look at other options, this 10 is small, but the concentration is high, so this should be slower than A. So B cannot be the answer. C, the volume is 20, concentration is higher than the one in A, so this reaction would be slightly faster than in A. So it would give us our hydrogen at a slightly higher rate. Then D, 30 centimeter cubic, which is lower than of A, concentration is higher than of A, so D cannot be the answer also. So A is the best answer. We look at question 13. Which of the following is an endothermic reaction? The formation of. So what we are seeing in this case, endothermic, basically we are saying there is basically absorption of energy inside. Then exothermic is energy is being given out. So what we see is hydrogen chloride bond. So to form the bond, they will need energy. So this basically bond forming is exothermic. Then bond breaking is basically endothermic. Then if you see silver from silver salts. In photography, this should be endothermic because we are breaking the bond between silver and the other compound. Then if you look at C, water from oxygen and hydrogen, so this is basically also breaking. Okay, this one is water from this is forming because we are combining oxygen and hydrogen, so this is bond formation, so this is exothermic. Water from the steam, so because the steam is hot, so for it to make water it need to give out energy, so that's exothermic. So also this one is incorrect, so basically B is the best option. Question 14. When carbon dioxide is bubbled in lime water, a white precipitate is produced which disappears with continuous bubbling of the gas into the solution. Identify the substance that causes the formation of a colorless solution. So we are bubbling carbon dioxide into lime water. What is lime water? What lime water is calcium hydroxide. Then once we bubble water into this is aqueous solution. This is the gas which will bubble. Once we bubble this, we are going to have basically calcium. So this one will react with carbon dioxide to form calcium carbonate. Okay, and this will be a solid which is the white precipitate plus basically water. Okay, this water which will be liquid. But once we continue bubbling carbon dioxide, what is going to happen is basically this calcium carbonate is going to turn into calcium hydrogen carbonate. So let us look at the options. The substance that causes formation of white precipitate. So this one is calcium carbonate. So it's not calcium hydroxide is out. This one is out. So it's between C and D. Then continuously will give us this one, not again calcium hydroxide, which is this one. No. So basically C is the correct answer. Number 15. Which information given in the table below is true about the industrial preparation of nitric acid? So basically what's the process? So the process is also a D process. It's not a bar process. Okay. So C and D are out. Then we remain with A and B. So we have also process. Then what are the starting material? So the starting material basically in this case we have A, nitrogen dioxide and water. This is basically the second stage. So this is the second stage, not the first stage. So A is out. So we have ammonia and oxygen. So these are the starting material. So B is the correct answer. Question 16. Iodine is one of the group 4 elements whose use in most everyday activities has increased. It is mainly used in water treatment. So is it in water treatment? So we need to identify the use. So water treatment is basically this is chlorine. So chlorine is one that we use for water treatment. Then we have used to bleach wood pulp to make paper. So this one again we use chlorine. Chlorine is also used, and hydrogen peroxide. Then number C, used in medicine. Yes, it is. Then number D, added to toothpaste to prevent tooth decay. This one is basically fluorine. So basically C is the best answer. Number 17. What is the structural formula of the ester formed when ethanoic acid reacts with propano? Okay, so propano is an alcohol. So ethanoic acid is given by CH3 then CO. So we have this group. Then we add it with propano, which is 3 carbons, then H7, then this. So when these two react, what is going to happen is this is going to form an ester and water. So what will happen is basically the ethanoic acid is going to lose this part. So it's going to lose this part. Then the propan, which is an alcohol, is going to lose H, so that these two they form water, okay, which is water liquid. Then the remaining these will combine to form a new element. So what it means here is we have one to C, so it's going to have this C and that. So it's going to combine to form this element, though it may have different isomers, but this is going to be this kind of the element. So now it needs to have how many carbons? 1, 2, 3. So it needs to have 5 carbons, the new element, but it need to have these O's in between. You've seen this? Yes. So let us look at the options. If you check out the options, what you discover is the one with 5 carbons, 1, 2, 3. So we have 5 carbons. You see that though this one has got carbon, so we need to know where. You've seen this? Okay, this is this part, then followed by 3 carbons and 7 hydrogen, which is in this case. So this one need to be this side so that it maintains this. So this part is that. So B is the best answer. So make sure that this part and 2 oxygen after C, this is maintained. Then you can break this one in whatever isomer. So B is the best answer. 18. The table below shows boiling point, ranges of fractions collected from distillation of sample of petroleum, which is crude oil. Which fraction contains the smallest molecules? So basically this one is straightforward. So molecules with a short carbon chains, they will have a low boiling points and they will be on top, while those with large carbon chains will have high boiling points. So the smallest molecules will be on top, so we'll have the lowest boiling point. So this should have the lowest, which is this one, which is A. Number 19. The diagram below shows the structure of a monomer. Select the polymer that can be formed from the monomer. So what we know is we have a double bond here. So what we need to write is this will be a bromine, the way it is. Then we are going to have chloride. Then this carbon bond and this carbon bond. Then we have down the H the way it is. Then down the H the way it is. So now what we are going to break is this double bond. So this bond will be this, then this side and this side. So it's this unit that need to be repeated, maintaining this on top and this one on top. So you need to look for that. So if you see here, there is no hydrogen. There is no hydrogen. So this one is incorrect. You look at here, there is a swap in chloride. So this one is incorrect. So bromide is supposed to be here, then chloride here, then we have a repeating units. If you look at C, we have of course chloride here but swapped, which is incorrect. So we need to start with this structure. Look at D, we have bromine, chloride, hydrogen. So this is the repeating unit, repeated unit. So D is correct. Question 20. All of the following are condensation polymers except. So which one of these is not a condensation polymer? So basically we need to identify. So if you look at toluene, toluene is formed from diols and dioic acid. So this one is a condensation polymer. Okay, then you see polystyrene. So polystyrene is basically, this is a man-made, and it's done by additional polymerization. So this one is not condensation. So this one should be the correct answer. A nylon is also this one is formed from diamonds and dioic acid, and this is basically one of the condensation polymer. Then if you look at carbohydrates, so carbohydrates, these are natural polymers, so they are made using the natural condensation polymers, and these are made by from glucose glucose to form starch. So this is not correct. So basically B is the correct answer. So basically this is how you answer these questions to get the optimal marks in this paper.